Today we'll discuss ISI's MTech QROR 2018 MCQ paper, and this paper again had some wonderful questions which are relevant to BStat and BMath as well as for CMI examinations. Now the first question is number of isosceles but not equilateral triangles with integer sides and no side exceeding 10 is. Now we can solve this question in two ways. First, we can solve this question using a direct formula, and the formula is number of isosceles triangles such that side length L doesn't exceed n is given by 1 by 4 3n square plus 1 when n is odd, and it is 3 by 4 n square when n is even. Now in this question we need to find number of isosceles triangles not exceeding 10. So that means value of n here is 10, which is an even number. So total number of isosceles triangles will be 3 by 4 into 10 square. So there will be 100 by 4, 25. 25 into 3 is 75. So total number of isosceles triangles will be 75. But then we need only isosceles and not equilateral. So that means from these total 75 cases, we have to subtract all the cases when this triangle is equilateral. So this triangle can be equilateral with side 1, with side length 2, with side length 10. So from these 75 cases, we need to remove 10 cases. So the total number of triangles which are isosceles but not equilateral will be 65, and that's your option number A. Another method could be just by choosing the values of sides. So suppose the sides are A and B, and we know that these sides, they must follow triangle inequality. So that means 2A must be greater than B, that is value of A should be greater than B by 2. So if we'll choose B as 1, we'll get A as greater than 1 by 2. So all the possible values of A will be starting from 2 all the way up to 10. If we'll choose B as 2, then A will be greater than 1. We'll choose A greater than 1, A as 2, but then this triangle, it should not be equilateral. So it'll start with 3 and we'll go all the way up to 10. And we can do that up to B equals 10, where A is greater than 5. So here value of A will be 6, 7 up to 9. If you will count them again, it will be 65, and that's your option number A. Now question number 2 is number of squares in this following figure. In one of the previous videos, we have discussed consecutive selections, and there we have discussed how to find total number of squares on a chessboard. Now it's a simple 4x4 chessboard. So first we will find how many 1x1 triangles can be formed. So 1x1 triangles will be 4 and then 4. So it will be simply 4 square. Now what about 2x2? So for 2x2, we need 2 consecutive horizontally and 2 consecutive vertically. Now 2 consecutive horizontally can be selected in 3 ways. In the same way, 2 consecutive vertically will be again 3. Now for 3, it will be 2 into 2, and then 4 cross 4 will be simply 1 into 1. So total number of squares will be 1 square plus 2 square plus 3 square plus 4 square, and there will be n plus 1, 2n plus 1 by 6. So it will be simply 30. So total number of squares in this following figure will be 30. And that's your option number D. Now question number 3 is number of trailing zeros in factorial 100. Now we know that total number of trailing zeros will be given by this limiting number of 5s. So for this question, all we need to do is we need to find exponent of 5 in factorial 100. So we'll use de Polignac's formula. So exponent of 5 in factorial 100 will be this greatest integer function 100 by 5 plus 100 by 5 square plus 100 by 5 cube. Now 100 by 5 is simply 20, and 100 by 25 is 4. Now this number, it is less than 1. So all the subsequent numbers, they'll be less than 1. Their greatest integer function will simply be 0. So now it will be simply 24. So the total number of trailing zeros in factorial 100 will be 24, and that's your option number C. Now question number 4 is we need to find number of common terms in these two sequences, and the sequences are 3, 7, 11 up to 407, and here it is 2, 9, 16 and then 709. Now we'll write general term for this sequence. So it will be 3 plus n minus 1, and common difference here is 4. So it'll be 4n minus 1, and for this one it'll be 2 plus m minus 1, and common difference is 7. So it'll be simply 7m minus 5. Now we'll find total number of terms in this sequence. So total number of terms in the first sequence will be 4n minus 1 equals 407. That is value of n is 102. So first sequence has 102 terms, and in the same way we can write it for second sequence, which is 7m minus 5, and this is equal to 709. So it will be 7m, and this is 714. The value of m will be 102. So both the sequence has 102 terms. Now we need terms which are identical to both the sequence. So that means we'll get this condition, which is 4n minus 1 must be equal to 7m minus 5. We can write n as 7m minus 4 upon 4, or n is 7m by 4 minus 1. Now we'll get integral value of n when m is a multiple of 4. So we need to find how many multiples of 4 are possible for the second sequence. Now we are also given that value of n is 102. So that means this 7m upon 4 minus 1, it should be less than or equal to 102. So condition we'll get is 7m upon 4 is less than equal to 103. That is m is less than equal to 412 upon 7, which is 58.85. So we need to find all those values of m which are multiple of 4 and which are less than 58.85. So total number of such multiples will be this greatest integer function of 58.85 divided by 4, and which is 14. So the number of possible values of m is 14. So these two sequences, they'll have 14 terms in common. So answer to this question is 14, which is option number B. Now question number 5 is, one needs to choose 6 real numbers x1, x2, x6 such that product of any 5 of them is equal to other number. So that means we'll get this condition when x1, x2, x3, x4, x5 and it is equal to x6. In the same way we'll get x1, x2, x4 and x6, it is equal to x5, and we can write this as x2, x3 and x6 will be equal to x1. So there will be 6 such conditions. Now what we'll do is we'll multiply all these expressions. So we'll multiply them. On the left hand side we'll get x1, x2, x6 whole to the power 5, and on the right hand side we'll get x1, x2, x6. So from here we'll get either x1, x2, x6 is 0 or x1, x2, x6 whole to the power 4 is equal to 1. Now we'll solve this condition. From here we'll get x1, x2, x to the power 6 will be plus or minus 1. Now when any one of them is 0 or other, they'll be 0. Suppose x1 is 0, then x6 is 0, x5 is 0, x2 is 0. So one of the condition is when all these numbers x1, x2 and x6, they're all 0. Now we'll consider the second case when x1, x2 and x6 is equal to plus or minus 1. Now we'll put value of x1, x2, x3, x4 and x5 as x6. From here we'll get x6 square is equal to plus or minus 1. So that means the only possible option here will be x6 square will be plus 1, and if we'll do it for all the numbers, then we'll get this condition that x1 square is equal to x2 square is equal to x6 square, and it is equal to 1. So that means value of all these variables must be either plus 1 or minus 1. Now we need to find in how many ways we can choose these 6 real numbers so that product of any 5 is equal to other numbers. So one possibility is when all these 6 numbers, they are 1. So that is a one case. Another possibility is when 4 of them they are +1 and 2 of them they are -1. So it will be 1, 1, 1, 1 and then -1, -1. So total number of such possibilities will be factorial 6 divided by factorial 4 factorial 2. So it will be simply 15. Next one will be when 2 of them are +1 and 4 of them they are -1. So it will again be factorial 6 factorial 2 factorial 4, which again is 15. And finally we have this condition when all the numbers they are -1, which is again one case. So total number of cases, so this is 1 plus 1 2 and then 30 32 32 plus 1 33. So total number of such choices is 33 and that's your option number B. Now question number 6 is we need to find volume of this region, which is given by mod x plus mod y plus mod z is less than equal to 1. Now this region, it is symmetric in all the 8 octants. So what we'll do is we'll find solution to this problem in first octant and then we'll multiply it by 8 to find volume of region in the entire 3D plane. So we'll take this first octant, then we have this plane which is x plus y plus z, it is equal to 1. So we'll have this plane, it will intersect x-axis at 1 0 0, y-axis at 0 1 0 and z-axis at 0 0 1. Now it says it is less than equal to 1. So that means we are talking about volume of this tetrahedron. So we know that volume of this tetrahedron will be 1 by 6 and then box product ABC. So it is 1 by 6 and each of these side lengths they are 1 1 and 1. So it will be simply 1. So volume in one octant is 1 by 6. So volume of this entire region will be 8 into 1 by 6 and that will be simply 4 by 3 and that's your option number D. Now question number 7 is GCD of all numbers of the form p square minus 1 where p is greater than equal to 7 is. We can write p square minus 1 is p minus 1 and p plus 1. Now we'll take 3 consecutive numbers p minus 1, p and p plus 1. One of them is divisible by 3. Now this p, it is a prime number. It is not divisible by 3. So that means one of p minus 1 and p plus 1 is divisible by 3. Now this p will be an odd number. So what we'll do is we'll let p as sum 2k plus 1. So we can write this as 2k into 2k plus 2. So it'll be 4k into k plus 1. Now we have this 4 here and then this k into k plus 1, it's a product of 2 consecutive numbers. So one of the numbers will be even. So it will be divisible by 8. So it'll be divisible by 3 and it'll also be divisible by 8. So the GCD of all the numbers of the form p square minus 1 must be 24 and that's your option number C. Now question number 8 is if a and b are two positive integers such that a equals k1b plus r1 and b equals k2 r1 plus r2 where r2 is less than r1 is less than b, then GCD of AB is same as. From Euclidean division algorithm we can say that GCD of AB is same as GCD of B and R1. So that's our first equation. Now from the second one we can say that GCD of B and R1, it is same as GCD of R1 and R2. And that's our second result. Now we have GCD BR1 in both of them. So from here we can say GCD of AB will be same as GCD of R1 and R2 and that's your option number A. Now question number 9 is alpha is the root of x square minus x plus 1 equals 0. So we know that x will be 1 plus minus root 3 iota upon 2. We can write this is minus and then minus 1 plus minus root 3 iota upon 2, which is nothing but complex cube root of unity. So value of x is either minus omega or minus omega square. So if we'll take x as minus omega, we'll get minus omega to the power 2018 plus 1 upon minus omega to the power 2018. So we'll write this as omega to the power 2018 plus 1 upon omega to the power 2018. Now 2018 when divided by 3, it leaves the remainder 2. So we can write this as omega square plus 1 upon omega square, and 1 upon omega square is omega. Omega square plus omega is nothing but -1, and that is your option number A. Now question number 10 is, a new flag of ISI club is to be designed with 5 vertical strips. So we have 5 vertical strips and we have 4 colors, which are green, maroon, red and yellow. In how many ways we can design this flag so that no 2 adjacent strips have same color? So for this first strip, we have 4 choices. So we can put any one of green, maroon, red or yellow. Now for this next one, we have 3 choices because we cannot put the color which we have already put on the first strip. So it will be 3 choices here. Now for the next one again, there will be 3 choices because we cannot choose the color on the second strip. Same for third, it will be 3, and then again it will be 3. So total number of ways in which we can design this flag will be 4 into 3 to the power 4. So it will be 81 into 4. So that should be 324, and that's your option number B. Now question number 11 is, if the system of linear equations has no solution, then we need to find value of lambda. So we know that system of equation will have no solution if delta is 0 and any one of delta I is unequal to 0. So first we'll find delta equals 0. So we'll get 2 minus 1 minus 1, 1 minus 2 1, and then 1 1 and lambda, and it should be 0. Now we'll expand it about this third row, then we can write minus 3 and then minus 3 plus lambda into minus 3 equals 0. We'll get 3 lambda equals minus 6, that is value of lambda is minus 2. So value of lambda should be minus 2. So we have already got the value of lambda, and if we want, we can show that any one of delta 1, delta 2, delta 3 will be 0. Now question number 12 is, we need to find a rank of this matrix. So we'll start with this elementary operation. We'll write R4 as R4 minus 101 R1 minus 10 R2. So here we'll have 101 minus 50, so it'll be 151, so it'll be 0. Here it'll be 202 plus 60, it'll be 262, it'll be 0. Same way this will be 0 and this will also be 0. So we'll get this matrix as 1, 2, 3, 4, 5, 6, 7, 8, and this is 6, 8, 10, 12, and it'll be 0, 0, 0 and 0. Now what we'll do is, we'll write R3 as R3 minus R2 minus R1. So here again, they'll all be 0. So we'll get this matrix as 1, 2, 3, 4, 5, 6, 7, 8, and then 0, 0, 0, 0, 0, 0, 0 and 0. Now it is not possible to reduce it further. So rank of this matrix will be simply 2, and that's your option number B. Now question number 13 is, we are given this matrix A, which is 2 iota 0, and we need to find trace of A to the power 10. Now what we'll do is, we'll find eigenvalues for this matrix. So it'll be determinant 2 minus x and then iota, and it'll be 0 minus x and it'll be 0. So we'll write 2 minus x into minus x and then minus plus 1 equals to 0. So we'll get this as x square minus 2x plus 1 equals to 0. So the value of x is 1 and 1. So the 2 eigenvalues for this matrix will be 1 and 1. Now eigenvalues for a to the power 10 will be lambda to the power 10 and lambda to the power 10. So they again will be 1 and 1. Now trace of a to the power 10 will be simply 1 plus 1 and there will be 2, and that's your option number A. Now question number 14 is, let A be 3 cross 3 real matrix with diagonal entries equal to 0. If 1 plus iota is an eigenvalue of A, then we need to find determinant of A. So one of the eigenvalue is 1 plus iota, and since the entries are real, other eigenvalue will be 1 minus iota, and then we'll have this third one, which is say lambda 3. Now we know that lambda 1 plus lambda 2 plus lambda 3, it is equal to trace of this matrix. Now all diagonal entries, they are 0, so trace is 0. So we'll put 1 plus iota plus 1 minus iota plus lambda 3 as 0. We'll get value of lambda 3 as simply minus 2. So the three eigenvalues are 1 plus iota, 1 minus iota and minus 2. Now we need to find determinant of A. Determinant of A will be lambda 1, lambda 2 into lambda 3. So it will be 1 plus iota into 1 minus iota into minus 2. So this is nothing but 2. So it is minus 4. So determinant of this matrix will be minus 4, and that's your option number A. Now question number 15 is, let G be a finite group of even order, then which of the following statement is correct? So here we are talking about number of elements of order 2. So in this group G, we have even order, that is number of elements is even. Now since G is a finite group, it will have one identity element, then it will have some elements which are self-inverse. Let number of such elements be n1. So there are n1 elements which are self-inverse, and then there will be elements which are not self-inverse. Let this number be n2. Now this 1 plus n1 plus n2, it must be an even number. Now we know that if the element is not a self-inverse, then it will have a complementary element. So that means elements in this set always occur in a pair. So this n2, it will be an even number. So if n2 is even and their sum is even, so that means 1 plus n1, it must also be an even number. So if 1 plus n1 is even, so it simply means this n1, it must be an odd number. So number of elements of order 2, that is number of elements having self-inverse, must be odd, and that's your option number B. Now question number 16 is, consider a large village where only two newspapers P1 and P2 are available to the families. It is known that proportion of families not taking P1 is 0.48. So probability that a family doesn't take P1 is 0.48. That means probability that family takes P1 will be 1 minus 0.48 and will be simply 0.52. In the same way, proportion of families not taking P2. So that is P2 not, it is 0.58. That means probability that a family takes P2, it is 1 minus 0.58, it will be 0.42. Now the next one is proportion of families taking only P2. So that means this is P2 intersection P1 not. So we know that it is given by P2 minus P, P1 intersection P2, and this value is simply 0.30. Now probability of P2 is 0.42. So this is 0.42 minus probability of P1 intersection P2, and this is 0.30. So from here we can write P1 intersection P2 will be simply 0.12. Now we need to find the probability that a randomly chosen family from village takes only P1. So that means we have to find probability of P1 intersection P2 not. So it will be probability of P1 minus probability of P1 intersection P2. So probability of P1, it is 0.52 minus probability of P1 intersection P2, it is 0.12. So it will be simply 0.40, and that's your option number C. Now the 17th question is, there are 8 coins, 7 of which have the same weight and the other one weighs more. So let the coins be A, 7 times. They are identical coins, and then we have this other coin which weighs more than remaining 7 coins. Now in order to find a coin, a person randomly chooses 2 coins and put 1 coin on each side of common balance. If the 2 coins are found to have the same weight, the person then randomly chooses 2 more coins from the rest and follows the same method as before. We need to find the probability that the coin will be identified at the second draw. So that means in the first draw, we must get 2 identical coins. So here this probability will be 7C2 upon 8C2. Now in the next one, we must have one identical coin and this one distinct coin. So from these remaining 5, we'll select one and then we'll get this as 1C1 divided by 2 from any remaining 6. So this is 7, 6 and it is 8, 7. This is 5 and this is 6, 5 into 2. So this 5 will cancel, 6 will cancel, 7 will also cancel. So this probability will be simply 1 by 4 and that's your option number C. Question number 18 is, let A1, A2, A3 and A4 be the vertices of a square. So we have this square which is A1, A2, A3 and A4. Now particle starts from A1 at a time t equals 0 and it can move to either A2 or A4 with equal probabilities. Suppose this probability is P. So this P is 1 by 2. Now we need to find this probability when t is 4, where t is the minimum number of steps required to cover all the 4 vertices. Starting from A1, it will cover all the 4 vertices when from A1 it goes to A2, from A2 it goes to A3, A3 it goes to A4 and then from A4 it goes to A1, or from A1 to A4, A4 to A3, A3 to A2 and then A2 to A1. Now moving in any direction, it is an independent event. So from A1 to A2, it will be P, A2, A3, it will again be P, it will be P and then P. So from A1 to A1, using this first route, it will be simply P to the power 4. In the same way, the probability of particle moving from A1 to A1 will again be P to the power 4. So the probability that this Pt equals 4 will be 2 times P to the power 4, where the value of P is 1 by 2. So it will be simply 1 by 8 and that's your option number C. Now question number 19 is, let x1, x2 and xn be independent and identically distributed with pxi equals 1 equals pxi equals minus 1 equals p and then pxi equals 0 as 1 minus 2p for all I from 1 to n. Then we have defined an as this probability x1, x2, xn is equal to 1. Second one is bn, which is x1, x2, xn as minus 1, and this third one where x1, x2 into xn, it is equal to 0 and we have taken it as cn. So for any random variable xi, there are 3 choices. Either it will be 1, 0 or minus 1 and their corresponding probabilities are p, 1 minus 2p and p. Now since it represents a binomial distribution, 1 minus 2p should be greater than 0, that is value of p should be less than 1 by 2. Now first we'll talk about an. Now an is this probability x1, x2 into xn and it is equal to 1. Now first we need to find in how many ways we can choose x1, x2 and xn such that its product is 1. Now one of the way of choosing it is when all the values they are 1. So if all the values they are 1, then we have only one case. Next one could be when n minus 2 values are 1 and then 2 values are minus 1. Then again their product will be 1. So from these n, we need to select 2 which will have the value minus 1. So it will be simply nc2. Next one will be all ones except 4 minus 1s. Here it will be simply nc4. It will continue till we have maximum number of minus 1s possible. Now since all these distributions they are independent, then we know that in any scenario px1, x2 into xn will be px1 into px2 into pxn. It will be simply p into p into p n times, because for plus 1 this probability is p and minus 1 also this probability is p. For each of these conditions this probability will be p into p n times and that should be p to the power n. So now we can write an. So this an will be, now this first one it is nc0 p to the power n. Second one will be nc2 p to the power n, nc4 p to the power n. So we'll get this condition as nc0 plus nc2 plus nc4 into p to the power n. Now we know that the value of this binomial series is 2 to the power n minus 1. So it will be 2 to the power of n minus 1 into p to the power n. So it will be 1 by 2 into 2p to the power n. Now we'll take this limit n tends to infinite an will be 1 by 2 and then 2p to the power n. Now 2p is less than 1. So if 2p is less than 1, then 2p to the power infinite will be simply 0. So value of an, it tends to 0. Now in the same way, we can prove the result for bn. So for bn, we'll start with minus 1, and then we'll replace minus 1s with plus 1s. So we'll again end up getting the same expression. So from symmetry, we can say this bn tends to 0. So an tends to 0 and bn tends to 0. Now we know that either this product will be plus 1 or this product will be minus 1 or this product will be 0. That means sum of an plus bn plus cn will be 1. Now limiting value of an and bn, it is already 0. So from here we can say limiting value of cn will then be 1. So answer to this question will be an tends to 0, bn tends to 0 and cn tends to 1, and that's your option number D. Now question number 20 is, consider a set of all functions from this set from 1 to m to 1 to n where n is greater than m. If a function is chosen from this set at random, find the probability that it will be a strictly increasing function. So we need to find this probability. So first we'll find total number of functions that can be defined from this set containing m elements to the other set containing n elements. Now for each element we have n choices. So it will be n into n into n, m times. So total number of functions will be simply n to the power m. Now in the numerator we need to find total number of strictly increasing function. Now if it is strictly increasing function, then that function will be a 1-1 function. So for these m elements, we'll need to choose m elements from this set containing n elements, which can be done in n, c, m ways. Now once we have selected these m elements, then we have to map them in an increasing order. So there is only one arrangement possible for all these numbers. So this probability will simply be NCM upon n to the power m, and that's your option number A. Now question number 21 is, we need to find angle between tangents drawn from the point 1, 4 to the parabola y square equals 4x. Now for this parabola, value of A is 1. We know that equation of tangent is given by y equals mx plus a by m. In this case, value of A is 1. So equation of tangent will be y equals mx plus 1 by m. Now we need tangents which pass through the point 1, 4. So we'll put the value of x as 1 and y as 4. So it will be 4 equals m plus 1 upon m. So we'll get this equation as m square minus 4m plus 1 equals 0. So we'll add 3 both sides. We'll get m as 2 plus minus root 3. Now we need to find angle between tangents. So we know that angle between tangents is given by m2 minus m1 upon 1 plus m1 m2. Now m2 minus m1 will be simply 2 root 3 and then 1 plus m1 m2. 1 plus m1 m2 will be 2. So value of tan theta is root 3. So value of theta is simply pi by 3, and that's your option number B. Now question number 22 is, the x-axis divides the circle x square plus y square minus 6x minus 4y plus 5 equals to 0 into 2 parts. We need to find area of the smaller part. So we have this circle whose center is at 3, 2 and whose radius will be 9 plus 4 minus 5 will be simply 2 root 2. So we'll draw this circle. We need to find area of this smaller part. Now first we'll find its intercept on x-axis. So for x-axis intercept, we'll put y as 0. So we'll put y as 0, we'll get x square minus 6x plus 5 equals 0. So it'll be x minus 1, x minus 5 equals to 0. So value of x is 1 or the value of x is 5. So this point is 1, 0 and this point is 5, 0. Now we need to find this angle. This length, it is 2 units. This length is also 2 units. So that means this angle is pi by 4. So this entire angle is pi by 2. So it is quarter of a circle. Now we need to find area of this segment. So we know that area of the segment is given by 1 by 2 r square theta minus sine theta. So it will be 1 by 2. Now what is the value of r square? R square is 8 and then theta is pi by 2. Sine pi by 2 is 1. So it will be simply 2 into pi minus 2, and that's your option number B. Now question number 23 is, we are given two sequences AN and BN. We need to find whether they are Cauchy sequences or not. We can write this AN as the summation k varies from 1 to n k upon k plus 1 square. So what we'll do is we'll add 1 and subtract 1. So we can write this as summation 1 upon k plus 1 minus summation 1 upon k plus 1 square. Now we know that this summation 1 upon k plus 1, it is not a Cauchy sequence. So from here we can say that this AN is not a Cauchy sequence. Now what about BN? We are given BN as C0, C1R, C2R square and Cn r to the power n. Now we'll take mod sign, we'll write it this way, and it will be less than mod of C0 plus mod of C1R mod of C2R square mod of Cn into r to the power n. Now any Ck, it is always less than equal to m. So it is less than or equal to m into 1 plus r square up to r to the power n. Now it will be less than 1 plus r square up to infinite. So we can write mod of Bn will be less than m upon 1 minus r. So that means this Bn, it will be a Cauchy sequence. So An is not a Cauchy sequence, but Bn is a Cauchy sequence, and that's your option number C. Now question number 24 is, we need to find sum of this infinite series, which is 1 plus 2 by 3 plus 6 upon 3 square 10 upon 3 cube, and this series, it continues up to infinite. We'll take this one on the left hand side. We'll write s minus 1 as 2 by 3 6 by 3 square 10 by 3 cube up to infinite. This right hand side, it is AGP. So what we'll do is we'll write the series again, but by displacing it with one term. So it'll be 2 by 3 6 by 3 square, and then we'll multiply it with its common ratio, which is 1 by 3. So it'll be 1 by 3, it'll be 3 square here and 3 cube here. Now we'll subtract this second series from the first. We'll get 2 by 3 into s minus 1, it'll be 2 by 3 4 by 3 square 4 by 3 cube up to infinite. Now this is nothing but infinite geometric progression. We can write 2 by 3 s minus 1 and will be 2 by 3 and then a, which is 4 by 9 upon 1 minus r. R is 1 by 3. So we'll get 2 by 3 s minus 1, and this is equal to 4 by 3. So value of s is simply 3. So sum of this series is 3, which is your option number B. Now question number 25 is, we need to solve this differential equation. So we can write this differential equation as y dx plus xy whole square y dx plus xy whole square x dy minus x dy equals 0. So we'll take xy whole square common. So we'll write xy whole square, and then we'll get y dx plus x dy, and L be equal to x dy minus y dx. Now we'll divide everything with xy. So we'll write xy and it'll be y dx plus x dy, and this is dy upon y minus dx upon x. Now this is nothing but dxy. So we'll get this as xy into dxy, and it'll be dy upon y minus dx upon x. So we'll integrate, we'll get xy whole square upon 2, and it'll be log y minus log x plus c. So answer to this question will be xy square will be 2 times log y minus log x plus some 2c, which is again constant c. And that's your option number D. Now question number 26 is, we need to find the sum of this binomial series. So what we'll do is we'll begin with this series, which is 1 minus x to the power n, and it'll be c0 minus c1x plus c2x square, and then minus 1 to the power n into cn. Now we'll multiply it with x. So we'll write x into 1 minus x to the power n. It'll be c0x minus c1x square plus c2x cube plus minus 1 to the power n cn into x to the power n plus 1. Here it should be x to the power n. Now we'll integrate this expression from 0 to 1. So here it will be this integral from 0 to 1, x into 1 minus x to the power n into dx, and here it will be c0 x square upon 2, and if we put x as 1, it will be c0 upon 2 minus c1 upon 3 plus c2 upon 4, and then minus 1 to the power n cn upon n plus 2. So that means sum of this series is equal to this integral I. So we need to solve this integral. Now we know that 0 to a fx dx is 0 to a f a minus x. So we'll replace x with 1 minus x. So we can write this integral as 0 to 1 minus x into x to the power n dx. So it'll be 0 to 1 x to the power n minus x to the power n plus 1 into dx. Now we'll integrate, we'll get 1 upon n plus 1 minus 1 upon n plus 2. So it'll be 1 upon n plus 1 into n plus 2, and that's your option number D. Now question number 27 is, we need to find number of real solutions of this equation. So we are given this equation, which is x to the power 7 plus 2x to the power 5 plus 3x cubed plus 4x equals 2018. So what we'll do is we'll consider a function fx, and which is x to the power 7 plus 2x to the power 5 plus 3x cubed plus 4x minus 2018. Now we'll differentiate it. We'll get 7x to the power 6 plus 10x to the power 4 plus 9x square plus 4. Now all these parts, they are even power with positive coefficients. So that means f dash is greater than 0. So this fx is strictly increasing function. Now this function is continuous and differentiable and is strictly increasing. Now since it is an odd power, it will start from minus infinite and it will go all the way up to plus infinite, and being a strictly increasing function, it will intersect x-axis only at 1 point. So number of real solution to this equation will be only 1, and that's your option number A. Now question number 28 is, we are given two functions fx, which is 1 when mod x is less than equal to 1, and 0 when mod x is greater than equal to 1, and gx, which is 1 when mod x is less than equal to 2, and 2 when mod x is greater than equal to 2. We have defined two functions h1 and h2, which are compositions of f and g. Now we'll take h1x. h1x is f of gx. So we'll take this function fx. We can write f of gx as 1 when mod of gx is less than equal to 1, and it is 0 when mod of gx is greater than 1. Now looking at the value of gx, so gx is 1 when mod x is less than equal to 2. So that means we can write h1x as 1 when g1x is equal to 1, that is when mod of x is less than equal to 2, and it will be 0 when gx is 2, that is when gx is greater than 1. So it will be when x is greater than 2. So this function, it is discontinuous at x equals plus or minus 2. So h1x, it is discontinuous at plus or minus 2. Now what about h2x? Now h2x is g of fx. Now g of fx will be 1 when mod fx is less than equal to 2, and will be 2 when mod fx is greater than 2. Now fx can take the value 1 and 0. So that means it cannot take the value greater than 2. So the only option that we have here is g of fx will be 1. So this h2x, it is nothing but a constant function. So this function will be continuous for all x belongs to R. So answer to this question is H1 is discontinuous at plus minus 2 and H2 is continuous. So H2 is continuous everywhere and H1 has discontinuity as plus minus 2, and that's your option number C. Now question number 29 is, we are given this function f such that f1 is 1 and then capital Ft is this integral from t to t square fx dx. So we write f of t as this integral t square fx dx. We need to find f dash 1. So we'll differentiate this. So we'll use Newton-Leibniz formula. So we'll put upper limit. So we'll get f t square into derivative of upper limit minus f t, and derivative of t is 1. So f dash 1 will be f1 into 2 minus f1. So f1 is 1. So it will be 2 minus 1, which is 1. And that's your option number C. Now question number 30 is, we are given this function and we need to find whether it has any local extremum. So we'll find f dash x. So f dash x will be 1 plus x square upon factorial 2 plus x to the power n upon factorial n e to the power minus x into minus 1 and then plus e to the power minus x, and if we'll differentiate this, we'll get 1 plus, now this is 2x upon factorial 2, so it will be x upon factorial 1 plus this one is 3x square upon factorial 3, it will be x square upon factorial 2, and here will be x to the power n minus 1 upon n minus 1 factorial. Now we'll take e to the power minus x common. So we'll take e to the power minus x common, then 1 will cancel, x will cancel, x square upon 2 will cancel, we'll get minus x to the power n upon factorial n. So f dash x will be minus e to the power minus x into x to the power n upon factorial n. So the only critical point in this case is x equals to 0. Now if we'll take x as 0, if n is even, there will be no sign change. In that case, there will be no extremum. So when n is even, we'll have no extremum, and when n is odd, then there will be sign change at 0. So rightmost is minus, this is plus, it will have a local maxima at x equal to 0. So answer to this question will be, it will have no local extremum if n is even, and it will have a local maximum if n is odd, and that's your option number D.